All right, so welcome. I wish I had everybody's names. I'll grab that. We've got, I guess you're Vishal. Yep. Safal, Pish, Kajal. I'm Dr. Barkley. I've been teaching math for a long time, algebra. So we're just going to talk about some of the things that the students struggle with, some of the concepts. And I'll go through a couple things, and then if you guys have any questions or some other things you want to talk about, that's great. But isn't adding fractions one of the big things they have a problem with? So, well, I titled this meeting Keeping It Simple, but of course what I'm going to do is not really simple. But I did a lot of stuff with PowerPoint here. I mean, we know, they know, your students know they have to get a least common denominator. But a lot of times they can't picture really what they're doing. So what I've done is make some, think about pizza. It's lunchtime, right? Sometimes a visual stimulation will help them, if you want to call them that. So suppose we have two pizzas, have a party. So one pizza you cut up into 5 pieces, the other one's 7 pieces. Then after the party's over, you see you have 2 pieces left out of the one, and you have 3 pieces out of the one that has 7 pieces. So the dark ones are the pieces that are left over. So this can represent your 2/5 and that your 3/7. We know we have to divide that into 35 pieces. So I've divided each one into 35. All right. So now we'll represent the 2/5 by these pieces right here, right? We know how many there's supposed to be. And so now we've got it out of 5 pieces. Now we've got 35. Now we put it together. And we've got, now you can see, all right, how many pieces did we break each slice up to? So you can count 1, 2, 3, 4, 5, 6, 7. Well, that was your denominator of your other. So altogether, we're going to have 14 pieces, right? Wish I didn't have to keep going back over here. So now we do the same thing with the 7-piece pizza. But we've divided that into, yes?
It would be much more effective if we actually had the pizza to share. Right, guys?
I'm sure they were.
Right? There you go.
Yes, thank you. All right, so anyway, we've got 3 out of the 7. But now we've broken it up into these 35 pieces. So you know where we're going with this. Then we're going to put them together. So how many divisions do we make on each slice? 1, 2, 3, 4, 5. Well, it happens to be the other denominator. Well, now we're getting to the point of this thing, and that is, how do you put them together? So we've got our, one on the left is our 2/5, one on the right is our 3/7. So now we combine them. So now we've got, this is our 2/5, this is our 3/7, and now we put them together. If you combine those 2 pieces, this is what you've got, 29 35ths, because we had 25 on, we had 15 on one, 14 on the other. So I think it helps if they can see this. They see, what does it mean? What does a fraction mean? What happens when you put them together? So, hang on a second. All right, do you think this is going to help some of your students? I don't know, you don't have to do anything so elaborate. I mean, I could give you this PowerPoint if you think it'd help. But if they see what a fraction really means, anybody have any questions about that? I mean, you know how to do this. You know how to add things. But I don't think that everybody sees, okay, why do you have to have all those divisions? And this can kind of show you when we go back to, well, I meant to say that back here, that 35 is the only number that's going to line up precisely with your pizza that's cut into fifths and the one that's cut into sevenths. So, before I do that, anything that's going to help your students visualize what's happening. Here's another one, distribution. This is what I did in one of my classes. Sometimes they struggle with distribution. So I draw these stupid little things so they see that you're going to have to combine that glass of water to, I don't know, what is that? Gingerbread man. Some block. Well, I was going to push this down here, but I didn't want to draw it again. The idea is you've got to multiply that times this, and then that times this. So these are things obvious to us, but just anything that makes it stick in their mind or it helps them remember what's going on. Another thing I did was let me blow this one up. I've got to do a different share here. Here we go. You know, when they're just trying to solve an equation. So you have bicycle equals watermelon plus, here's pizza again, times R. You know, if they see something besides just a regular mathematical symbol, sometimes it goes. So, I mean, it looks like a silly little thing, but just something to make it stick in their mind. You got to subtract that watermelon from both sides. And then divide by this pizza thing, right? And then you can get R. So here it is, bicycle minus watermelon or pizza. Just draw some funny shapes and things like that. Then, so let me go back over to the other one. There's that one again. Oh, there was one other one here. How do you remember that you raise anything to the 0 power, it's 1? So I just drew a picture of Jupiter here. So it doesn't really matter. It could be anything complex. Whatever kind of expression you imagine, if you raise it to the 0 power, it doesn't matter. It's always just 1. So these are just a few of the things that sometimes they struggle with. And these little tricks can help. So now let's go to do another fraction. How about this one? 5/12 plus 5/18 minus 2/27. Well, it's not quite so obvious then what our least common denominator is. So I don't know if you teach this technique to your students. I do in my class, but you need to build the least common denominator. So do you know how to do that from factoring each one of these? So you got 12 equals 2 times 2 times 3. You've got 18 equals 3 times 3 times 2. You have 27. Well, you know what? I'm going to change this, make it a little bit more interesting. I meant to make that 28. That's going to be better. So make that 28. All right, now how does this factor? 2 times 2 times 7. So your least common denominator equals, what is it? And let's look at twos. You have 2 of them here, 1 of them here, 1 of them, or 2 of them here. It appears the most times twice, so that's how many you need. Now threes appears, 1 of them, and 18 appears twice. You've got to have both of those. And you only have 1 7, and that's how you can build the least common denominator, which is going to be a lot less than trying to multiply multiplication. You don't really want to have to do that. So what is this? Least common denominator is 4 times 9 times 7. Can you do that in your head? So, you got it. 252. All right. I mean, this is the standard way. This is the way, really, is the best way to teach them, especially if you've got more than 2 fractions. So, so you guys have done this and used this before. Good. The other nice thing, though, is you can look at this. 12 is missing what? Let's look at our least common denominator. We've got 2 times 2 times 3 times 3 times 7. 12 is missing, it's got 2 2s and a 3. It's missing a 3 times 7, right? So that says we need that. We need to multiply top and bottom by 21. Now 18, it's got a 3, it's got 2 3s, it's got 1 of the 2s, it needs a 2 and a 7. So you got 14 times 14 there. Now the 28 has 2 of the 2s and the 7, but it doesn't have the 3s, so that says 9. So 21 times 5 is, what is that, 105. Our denominator is 252. Plus 5 times 14 is 70, or 252, minus 45 over 252. Okay, if you guys can do this in your head, right, you get 130? 130 over 252. Okay, now you need to reduce it. How do you teach them to reduce it? You have them factor as much as they can, both of them. Okay. I mean, they have stuff in their calculator. Here's the problem. People nowadays don't think in terms of fractions anymore, do they? They're too reliant on their calculators. So they turn everything into a decimal. But we want to make them think in terms of fractions. And that's why I want to do the pizza thing. So they think in terms of those fractions. All right. Now there's shortcuts. If they just can't get it, if you've got just two fractions, say you've got 2/5 again, plus 3/7. There's this technique. You ever see that? Means multiply this up here, multiply this up here, multiply those together, and then add what you've got in the top. So that's 14 over 35 plus 5 times 3 is 15 over 35. Let me show you this. So it's 2 times 7 over 35 plus 3 times 5 over 35. So that got us our answer in just a diagram. That sometimes is useful. I don't know, what do you guys find that helps? Any tricks you guys have?
Basically what I do is I find the LCM or lowest common denominator and help them with that.
Well, that's the big thing. That's the big thing. But part of it is understanding you don't add these two denominators, right? Again, that's why I like to go to the pizza thing. If they see that, they see, oh, well, yeah, you don't add the 35 and 35 with 70. You don't have 70 pieces on that pizza. So anyway, all right. Good, good. Well, so these are just some of the basic things about algebra that they struggle with. Are you guys doing any trigonometry or any of that?
Sometimes the other trigonometry.
So, you know the SOHCAHTOA thing? Anything that helps them stick it in their minds. How about just a regular inequality? In high school, they teach, okay, this is an alligator's mouth, right? And it eats the bigger one. Do you guys use that one?
I use the bigger points. So there are 2 points on one side, meaning it has bigger points.
Oh, sure, that's how we're supposed to teach it, isn't it? We're supposed to teach it like this. So here's 3 and here's 1. The one to the further to the right has to be greater. But they don't always do that. Students are lazy. They don't want to do that. So any little trick, any visual thing you can do to draw, to make them, so it's a little different than what they're used to. Here, for fractions, they can go to Khan Academy. There's so many things out there on the internet. But it's pretty much all the same. You got to make something that makes them stick in their mind. Something a little bit different. So anything you can think of, that's fine. Just draw something stupid, like I do. I'm a terrible drawer. As you saw, I'm not an artist. Okay. Jupiter's my favorite planet, so I like to do that. All right, well, I want to open it up to you guys. If you have any other things that you want to talk about.
So often, whenever I have a student and then they don't understand something, I always start writing on boards because I usually feel like if they see it on board, they have a bigger picture rather than writing on their paper.
Ah, good. So you're saying right on the board. Well, now wait a minute. So do you do it or do you have them do it?
I do it, I mean, like, I always start like, if they have any problem, I always start writing on the board with the base of it. Like, I do not go on the problem, but I start writing the base, like where it comes from, or like with another example. So, yeah, I start doing that first, and then I ask them if they want to come, and then show them.
Right.
Often the student comes, but like, some of them are like, no.
Well, you know, we're not supposed to work out any homework and stuff for them. So you find something similar. I like to do this. I make them go to the board and write it. If they have to write it, then it helps them think a little bit more about it. So, but I think you're right. Writing things down does definitely help. Good. Any other things that students are struggling with that you notice? You're all math tutors, right? So,
Yeah, I've seen like if there are multiple coefficients in one like addition problem, for example, 2 pi r plus x, and when we have to multiply it with some number x, then like we just do it to the second or just the first. Something like
okay,
that.
well, let me write that down so I understand. So you have two,
X
two-
times it's
you have x
times on bracket.
like this
No, x
After
after x band.
after, okay. So like this.
Yeah, and 2 pi x plus y. Let's suppose y.
One,
Y.
well,
So whenever
Okay.
they are solving those parentheses problems,
Yeah.
they usually just multiply the first one and then they skip the second.
oh, so they're doing this. Are they getting the x squared part right? But they're not doing this.
Yeah.
They will just
Okay.
leave it as y.
Any tricks to help them remember to do that? Well, I showed you that one thing where I drew some funny stuff
Yeah.
there.
Whenever if I'm working on board, I just like point an arrow from X to
Okay.
one, and then point an arrow from X to another.
I give them an example mostly, like if you need to distribute something to 2 people, then you just give it to one or something like that.
So you say that again? Just another example like this?
Yeah, I give them like in a person, like if you are distributing something to 2 people, do you just give it to one? Or
Oh, yeah, I like
That's
to
a
do
nice
that.
one.
You got 2 kids, you
Yeah,
can't give
exactly.
one of them candy and not the other, right?
That's a nice
Yes, good, very good. That's a good one. Here's one that pops up every once in a while. Suppose you're factoring by grouping, and so you get this. You get 2x plus 1 plus 4x plus 2. Let's see. So now you're doing factoring by grouping, right? You can take something out of here, but let me do it the other way around. I want to do it this: 4x plus 2 plus 2x plus 1. So I underline both of those things. You got to find similar factors. So you get 2 out of here, and you get 2x plus 1. Here's the problem. This is already 2x plus 1. They know what to do if it's otherwise, but what do you do?
Yeah.
Somehow you got to let them know they got to factor out 1. They've always got to factor something out. So, right? Because you got to have the same here as you have here, and you've got to have something out there. So, so the answer is what? 2 plus 1 times 2x. This wasn't a very good example, was it? Because it wasn't I should have done it with a quadratic. So this is just 3 times 2x plus 1. Well, that's another way. If we combined that, it would have been 6x plus 3, and then they could have seen. It's an alternate way, but here's what they often forget to do when you're factoring by grouping is take out that 1. So yeah, that's a little tricky, isn't it?
And then often I find the problem with students like on the first one, 4x plus 2 plus 2x plus 1. Because we can like straight away add those terms, right? Like 4x and 3x. Often students do not find those. So if I'm tutoring them, I just give an example of an apple and mango. Like I just ask them if you have 5 apples and 4 mangoes, what would be the total result? Would it be 9 mango apple? And then
Okay, so you're saying
just make them group it.
So you're saying they try to combine those. So you're saying, okay, do 4 apples squared. You put the squared on there?
Let's just take an example of the first one.
Okay.
So in place of x, I just say them like, okay, there are 4 apples plus 2 mangoes plus 2 apples plus 1 mango, right?
Oh, okay.
So now, if we are adding those, we cannot add apple and mangoes. We have to find apples and apples.
Hey, what does a mango look like? There you go. It looks like that. That sounds good. It is like that. Yeah, you're right. I mean, anything, whether they're a square term and a first order term, or you're right, they can't add the 4 and the 2. They've got to know that, yeah, that's not allowed. So make it apples, oranges, mangoes, whatever. I've done that too before, so that's good. That's good. That made me think of another. Well, I can't think of it right now. But anyway, well, we've covered a few little tricky parts, at least the algebra stuff. So.
Okay, one more thing, right? The one we did with the discount factor. So you're trying to get the denominator the same, right?
Yes.
So oftentimes they don't get that. Why are we multiplying with 21 over 21? And so for that I had to I find myself curious like a lot of time, like 1 over 1 first.
Oh, okay. So when you're saying, I think what you're saying is,
yeah, oftentimes
yeah, 21 over 21. Yeah.
They feel like where it's coming from. They just don't get it. And oftentimes I have to say like, so we just multiply the 1 over 1, right? Multiplying by 1 doesn't change anything. And then I multiply the 21 to that 1. After that I have to introduce that 1 over 1 first.
Okay, so you're doing this, if I understand, so you got 5 12s maybe.
Yeah.
So you say, okay, let's first do 1 over 1.
Yeah.
Okay? And then you say, okay, now let's do 21.
And the thing is, they don't understand that multiplication of 21 to the 5, but they understand the multiplication of 21 to the 1.
Yeah. Okay.
And then we can then I can establish that 21 over there.
So the principle is that they multiplying by 1 doesn't change anything. You really haven't changed the fraction. Okay, so well, that made me think of another. What was it? Oh, when you have something like this, you have 5 halves times 2 sevenths. Actually, they're okay with this. You cancel, right? Cross cancel. So you got 5 Septs. What they don't realize is that really you need to replace this with 1. Because what if you do this? What if you have 5 halves times 2? Now, one thing they need to understand, if you multiply by an integer, you can think of it as 2 over 1. You can do that. When you do that, it doesn't replace that with 0. It's that. Yeah, I have students struggle with that sometimes. So, okay. Good. Do you have any other situations that are hard to explain to students? Well, like I say, when it comes to adding fractions, working with fractions, I recommend that you don't let them just use their calculator all the time. Just make them think in terms of fractions. Well, and when you teach, I can't convert stuff to decimal, but fractions, I can work those in my head. Tricky little things to do multiplication in your head? These are just mathematical brain exercises, like what's 12 times 21? Can you do that in your head? Maybe you can, but there's a little trick you can do. How about you do this? It's 12 times 20 plus 1. Now 12 times 20, now that's easier to do that than it is to try to multiply this in your head. So that's a nice little trick. So we get 252, right? What about 5 times anything? 5 times 72. Now, any multiple of 10 or divisor of 10 of 5, for example, 0.5. You know how to take half of 72, that's 36. Then you just add a 0. So, now, I don't know if you're going to be able to teach your students these tricks. But if you wanted to impress your friends, you could do these little mental things, and it makes it really slick to do some of this stuff in your head. Okay. Well, I don't have anything else, unless you guys have any more questions. Okay. Good thing is you're getting paid for this, right? We're going to do a series of these. What kind of things do you think would help in your tutoring? Any of you do online tutoring?
Not enough. We just sit in a hall.
Yeah, okay. There's going to be an opportunity come up pretty soon to proctor physics exams, proctor my physics exam. I want to have some training on that if you guys are interested in doing that. Yeah. So anyway, okay, good. All right, well, thanks for coming, and we'll talk to you later, okay?
Thank you. Have a good day.
You too.